All right, so far in this class, we've talked about linear models in general. We've talked about least squares in particular, and why least squares makes sense in many cases. You've proved that least squares is the best linear unbiased estimator. You've derived how to calculate the beta coefficient to understand the relationship between predictor variables, the x variables, and some outcome y. You've derived the confidence interval to be able to talk about uncertainty in these coefficients. You've gained a greater understanding for what these confidence intervals actually mean. You've learned how to check the assumptions of these least squares models and how to visualize those checks. You've learned what to do when the assumptions are not quite met, so different types of models that you could fit instead, things like generalized least squares, weighted least squares, robust regression, transformations. And so now finally we're going to talk about, once you've landed on your model, how to actually visualize the results so you can present them to a stakeholder to be able to help them be able to understand what's happening in the final model that you choose. And so the main way to visualize linear models is via a plot called a forest plot. And this is a plot that shows the coefficients, the beta coefficients, along with the uncertainty or the confidence intervals. And so this is the final plot that we're going to be working towards here. And I'm going to show you how you can build up to this plot using ggplot and some of the functions that we've learned already. So just to step through what this plot is showing, here I fit a model using the MT-CARS data, and I am predicting miles per gallon. And I'm seeing how straight engine, whether or not the engine is straight in the as opposed to V-shaped in the car, how that influences miles per gallon, along with number of forward gears, number of cylinders, and whether or not the car has a manual transmission. So that's what the variables here are on the left. And on the x-axis, I'm plotting the coefficient, the beta coefficient, along with the 95% confidence interval. And so each of these dots in this forest plot are the beta coefficients for each of these terms. And then the lines here indicate their confidence intervals. So that shows the 95% confidence interval here. And then this dashed line here is at the null, so that's at 0. And so if there was an effective 0, that would indicate that there was not a relationship between the variable and the outcome, miles per gallon, holding everything else constant. And I've also colored my points to indicate whether or not the p-value is significant at the alpha equals 0.05 level, so whether or not there's a significant p-value. And then finally, I've annotated a single point, and that's to draw attention to that point that I want the audience to have an extra understanding for. And so in kind of the story behind this model, I was asked by a stakeholder to fit this model in order to understand better the relationship between manual transmission, whether or not a car has manual transmission, and how that impacts miles per gallon. And so because that was my goal, that's going to be the point that I'm going to annotate. And so I've added this annotation saying having manual transmission versus automatic yields an expected change in miles per gallon of 4.32 with a 95% confidence interval from 0.1 to 8.5, holding all other variables constant. Okay, so let's talk about how to actually build up to a plot like this. And so the first thing that you're going to do is fit your model and tidy it. So this is going to use some of the same tactics that we learned in the last class. And so I'm going to load the Broom and the ggplot packages. And then I'm going to fit my model. In this case, I'm fitting a linear model where I'm predicting miles per gallon using those 4 variables. My data set is MT-CARS. And I can use the tidy function from the Broom package to get a nice square or rectangle shaped data frame out of that mod object. And I'd like for this to include confidence intervals because I need to plot those confidence intervals. And so I'm going to set the parameter conf.int equals true to do that. And now I'm going to drop the first row. And the first row, if you take a look at this mod.tidy object, if you're running this code along with me, you'll notice that first row is the intercept. That's always going to be the case when you use the tidy function. If you have a model with an intercept, the first row will be that intercept. And in the forest plot, I'm not very interested in plotting the intercept. Most of the time, the intercept is not of a lot of interest to stakeholders. Now, sometimes it is, and in that case, I would include it. But in this case, it isn't, so I'm going to go ahead and drop it. And just as a reminder, the way you interpret that intercept is basically if all of these other variables are 0, then that intercept is going to be what we would expect miles per gallon to be. And so that might be a quantity of interest, but it also might not. And since in this case it isn't, I'm going to go ahead and drop it. All right, so now I'm going to take that tidy data frame that I just created with my model terms, and I'm going to put it into a ggplot function. I'm going to map my aesthetics. On the x-axis here, I want the term. On the y-axis, I want the estimate. And so these are these terms here, term and estimate, those are consistent values from when you use the tidy function. Your terms will always be in a column called term. Your beta coefficients will always be in a column called estimate. And your lower bound and higher bound and upper bound of your confidence interval are going to be in conf.low and conf.high. And so I want to set my y min to conf.low so that the minimum here is going to be the lower bound. And I want to set my y max to conf.high so that it shows the upper bound. And then finally, I'm going to use geom point range to be able to create a range. And so that's how you create the geom point range, is how it creates a line, basically a range here with a point in the middle. And the point is going to be my y value, my estimate. And then the bottom of the range is going to be my conf.low. The top of the range is going to be conf.high. Okay, so looking at this plot, what do we think can be better? So this is okay. It gets across the picture, but I think that there are several things we can do to improve it. So let's build up to that. The first thing I think that would improve this is if we just turn it. So people sometimes have a hard time visualizing things up and down like this. And especially for forest plots, it's much more common to see the estimates on the x-axis and the terms on the y-axis. So let's flip those coordinates. So in ggplot, there's a coord_flip function that will flip the x and y axis. So I'm going to go ahead and do that. All right, and what else can we improve in this now? Well, let's update the axis labels. So there's a labs function that you can set the x and y axis labels. Now, notice here, because we flipped the coordinates, these labs are going to be on the opposite of what you're expecting. So for example, to update what is now the y-axis, I need to use x equals because ggplot still thinks that's the x-axis, even though it's flipped. And to update this bottom axis that's normally the x-axis, I need to say y equals. And so this is a little bit of, you've got to kind of think through a little bit the flipping. Maybe you can do the flipping as your final steps so that you can sort of keep that all straight. And so because it's kind of obvious that these are terms, I'm going to just get rid of that axis label. And then down here, I'd like to indicate that these lines are telling us the coefficient along with the 95% confidence interval. All right, now instead of using these variable names like VS, gear, CYL, and AM, those are not intuitive, and a stakeholder likely doesn't know what those mean unless they're really familiar with my data set. And so I'm going to want to update those to actually be labels. And so what I'm doing here is I'm updating the labels, and I'm doing this manually. There are several ways to do this that wouldn't be manual that I'm going to show you in just a second. But because there's only 4, I'm just doing it manually. And so what I've done here is I've taken the mod_tidy data frame. I've added a column called labels, and I've set this to indicate the labels for each of these. And now instead of my x-axis being terms, it's going to be this new value labels. So that's the manual way to do this. There are better ways, especially if you have a lot of variables. And so I encourage you, if you're trying this out, to look into merge, or if you're familiar with the tidyverse, look into left_join. And those are going to be better ways to basically create a key to be able to map your variables to your labels. So now this is looking much better. I've got nice labels here on my x-axis. I have a nice y-axis label. I flipped it so this looks like what I would expect for a forest plot, but there's still some things I could do to fix this up. For example, I can add a reference line at the null. And so to do that, I'm going to use geom_hline. And so notice again that this is expecting that this is a horizontal line even though this looks vertical. And that's because we had this chord flip here. And so because we flipped the coordinates, it looks like this is the x-axis down here and this is the y-axis, but under the hood, ggplot still thinks that this is the y-axis on the bottom. So we need to be kind of operating under that mentality. So I'm creating a line here, setting the y-intercept to 0, again, because ggplot thinks this is the y-axis. And then LTY equals true, this is the line type, equals 2. That's going to set this to be a dashed line. So I'm adding a reference line at the null, and that helps my reader or my audience kind of draw attention to where a non-significant effect would be. So an effect that would be null would cross this line. So these confidence intervals that cross the line will have p-values greater than 0.05. And these ones that do not will not. And ones on this side of the line are going to have positive coefficients, and on this side of the line will have negative coefficients. Okay, now we're going to update the theme. And so the typical ggplot theme has this gray background, along with some other defaults. I'm partial to theme_minimal, but there are several themes that you can update to depending on your audience and depending on kind of what this is for. If this was for a journal article, I might use a different theme than if this was for like a blog post or a tweet or something like that. So you can check out all of the available themes by going to this link if you go to ggplot2.tidyverse.org/reference/ggtheme.html. It'll show you all of the different potential themes along with examples of what they look like. So you can pick the one that you think would be best for whoever you're demonstrating the model to. All right, now the next thing that's important in plots is that you want to make sure you draw attention to the points of interest. And so, for example, if your stakeholder was interested in which coefficients have significant p-values, you might do that. So to do that, we're going to color these using the color parameter here in the aesthetic, the AES, under the ggplot function. And what I've done here is I've used an if-else statement to say if the p-value, so this p.value is a column in the mod_tidy data frame. And I'm saying if that column consists of a value that's less than 0.05, I want to give it a title p less than 0.05, and otherwise I want it to be p greater than 0.05. If, for example, I wanted to highlight just the manual transmission, I could change this to say if else term equals am, because that's the name of the variable, then this is manual transmission, otherwise it isn't. And that would be maybe if I just wanted to draw attention to this one single point. Or maybe you want to draw attention to a different point. Maybe the whole reason you were fitting this model was to look at whether the number of forward gears here was an important predictor for miles per gallon, in which case maybe you would highlight that point. And so the point that you highlight or the points that you highlight are going to be dependent on the audience and what they may or may not be interested in. And so this is how you color those, differentially color those values. Alternatively, you could just add a variable here that consists of this if-else statement to the mod tidy data frame and then say color equals that variable name. That would be another way to do this. And then once you've set the color, if you'd like to customize it a little bit, you can use the scale_color_manual. And what that lets you do is do things like choose the values. And so I chose for the values to be blue and black, for example. It lets you set a name here for your legend. So I've just set that to be blank because I think this legend is pretty self-explanatory. I don't think it needs a title. But if you'd like to have a title, you could add that here. All right, the next step is highlighting an important point. And so to do so, you can use the annotate function, and you can annotate in all different ways. One way is to put text. And so what you do is you specify what manner in which you'd like to have an annotation. And so in this case, I would like to have some text here. And you say where you want that text to be. And so I specify that I want it to be at 2.25 on the x-axis and 5.9 on the y-axis. So that's going to be somewhere around here. And then you specify what label you'd like it to have. So that's where I wrote out having manual transmission versus automatic yields an expected change in miles per gallon of 4.32, holding all other variables constant. And then you can specify things like the size or other parameters to specify kind of how you want that text to look. And then finally, in addition to adding text, you can also add things like arrows. And so now instead of saying annotate text, I'm going to say annotate curve. And this has a couple extra parameters because I need to tell it where I'd like this curve to start. So x equals 1.5 and y equals 4.75. That's where it starts. And I also specify where I want it to end. So x equals 1.2 and y equals 4.32 is where I wanted it to end. And then I'm going to say arrow equals, and then arrow length equals, this is how you'd like it to be length. And so in this case, I'm going to say unit 0.03 NPC. And so there you have it. That is my final plot here. This shows kind of how we built up to this using ggplot to be able to show the final results from this model. And so this is the final step. After you've done your checks, you've visualized your checks, you've determined the final model that you're fitting, this is the final step. And of course, if you're including a figure like this, you'd always want to include an explanatory caption that describes the type of model that was fit and how you made the choices that you made. So what I want you to do is I want you to go ahead and take the model that you chose in the previous application exercise, and I want you to create a figure like the one discussed today. So I want you to create a forest plot of that model. And I want you to include a caption that explains what this figure demonstrates, and add that to the RMD file that you've been working on, and knit to a nice HTML file, and then go ahead and upload that to Canvas.